In this video, we're being asked to solve these two equations simultaneously using graphical means. Now, when we're solving for simultaneous equations, what we're doing is we're saying that an x value and a y value that works in one equation also works in the second equation, hence the title simultaneous equations. So what we need to do if we're going to solve this graphically is get the equations into a form that's easy for us to graph. And one that we'll use here is the gradient and y-intercept form, which is y equals mx plus c. So we can see that the first equation in purple is already written in that form. We have y equals 2x plus 1, so the gradient is 2 and the y-intercept is 1. We need to rearrange the second equation so it's in the same form. So 3x minus y equals 1 can be changed to be in terms of negative y by shifting the 3x across to the other side. In other words, making it 1 minus 3x. And then just to get y by itself without the negative, we'll multiply through by negative 1. So we get an equation of y equals 3x minus 1. They're now both in y-intercept and gradient form, and we can go through and easily graph them. So let's have a look at what the graphs look like. The first one we'll have a look at is y equals 2x plus 1. So we can see here in purple that we've got a line that goes through the y-axis at 1 and has a gradient of 2. Now we can tell the gradient's 2 because if we start at the y-axis where it intercepts at 1 and go across 1 unit, the line will go up 2 units. So it has a gradient of 2. Every time we go across 1 unit, the line moves up 2 units. Similarly, y equals 3x minus 1 has a y-intercept at negative 1, so we can start the line there. And it has a gradient of positive 3, so every time we go across 1 unit, the line moves up 3 units. Now to solve them simultaneously on a graph, what we then need to do is find the point of intersection, because that point of intersection indicates an x and a y value that works in both equations. Now if we do that and go through and find the point of intersection for these two graphs, we get the point where x equals 2 and y equals 5. Now checking the meaning of this, if we substitute these values back into the original equations, we see with the first equation, if you put x equals 2, you'll find that 2 times 2 plus 1 will equal 5, which is the y value. So 2 and 5 does work in the first equation. In the next equation, we have 3x minus y equals 1. And if we substitute 2 for x and 5 for y, we get 3 times 2 is 6, and if we subtract 5 from that, we get 1. So the equation is true for the second line as well. So to summarize that, if you're being asked to find the solution to two simultaneous equations using graphical means, it means go through and actually draw the graphs and find the point of intersection. And from that point, the x value and the y value give the solution to the original equations.